In this chapter, we will be reviewing and introducing some ideas in statistics. In this lesson, we'll start by looking at measures of central tendency.
Okay, hi everybody. So now we're going to start a chapter on statistics. And you really can't overstate the importance of understanding a little bit of statistics, particularly in our culture, because you are bombarded by statistics on a daily basis. As soon as you go online, you're pelted with advertising. You watch TV, you go drive down the road, and frequently they include statistics in these advertisements and whatnot. But it's not just advertising; it's all over the place. Politicians use statistics. Companies are always using statistics to look at how they can hit their markets better. Engineering scientists use statistics to figure out kind of what they need to do or come up with conclusions based on their data. It's about analyzing data. There's so many places that statistics really features prominently in our society here. So just a basic understanding is really important. You cannot overstate this. So statistics is the science of collecting and analyzing numerical data. Now, you wouldn't think collecting would be that big of a deal. Actually, it's fairly complicated, and there are a lot of issues that need to be taken into account. Now, we're not going to get into that, but just understand that trying to get a good representative set of data that you can analyze and then give you information about the entire group, that can be tough. We're going to look very briefly at analyzing the data, specifically the numerical data. Okay, so what we typically do is we go out into a population. Okay, so there's going to be a group of individuals that we're going to be studying. Now, it could be any group of individuals. It could be the classroom you're in. It could be the school you're in. It could be the city or larger than that, the country that you're in. Okay, but typically we don't talk to everybody in that population, even though they're affected by the work that we're doing. We usually only look at a sample, just a small group. So in the collecting of the sample, the issue becomes, like I said before, just trying to get a representative sample so that when you determine your statistics, they actually tell you what's going on with the whole population. That's not always easy to do. Anyway, once the data is collected, we can analyze it in a bunch of different ways here. I mean, let's face it, one way that you're going to be very familiar with here is your teacher will typically take your marks for a given exam and come up with an average, okay? Because you want to know what the average of the class is. Because deep down inside you know that where you rank in the group is important to one degree or another. Okay, that there is a comparison. Okay, you want to know if you did better than average or worse than average. Okay, in fact, sometimes it's not even the mark that you got that's significant. It's how it compares to the average, right? Because if you got a really high mark and the average is really high, well, okay, that's not nearly as rewarding as getting a really high mark when the average is fairly low. Anyway, so one of the things we're going to look at here are these measures of central tendency, or at least this is where we're going to start here. And I suspect this is going to be review for almost everybody that sees this, okay? So once the data has been collected, it's useful to describe the data by use of a single central value. Now, that is true. It is nice to have a number, one single number to kind of give you a sense of what the data is doing. But anytime somebody quotes a statistic to you in isolation, that statistic is useless. Let's just throw that on the table here first of all. If all you're told is the average, that doesn't convey enough information to do anything with. So just want to make sure that that's clear here. It's a good starting point. It's a really good starting point. But it's not enough. You really do need to move beyond here. So even understanding a couple of the different measures of central tendency makes a huge difference. So the first one we're going to look at here, is the mean. And when we say mean in mathematics, that means basically what you think when we say average. Most of us equate average with the word mean, where you add up all the values and then divide by the total number of values. Now, technically, each one of these things is an average. Okay, because an average is just a word that we give to a measure of central tendency. It's just the same word as that. But most of the time you equate that with the word mean. And we use two different symbols. when we talk about the population, we use the little mu here. Maybe I'll zoom in a little bit here. Okay, we're going to use this symbol right here, this mu, to represent the population mean. And if you're talking about just the sample that you collected, we usually use the x with a bar over top, okay? And that indicates that the measure that we're working with right now is just the average of the sample that we took. And usually we're going to hope that this is going to be close to what that would be so that we can make some accurate guesses as to what the population behaves like. The median is the middle value of a set of data, okay? So the median is calculated by, first of all, you sort the data in numerical order, and then you just take the middle number. Now, if you've got an even number of data values, then there is no middle. So then what you do is you take the mean of the middle two values. Okay, so if there's an odd number of data points, okay, like I've got my 5 fingers here, this is the median. This is the median. If you've got an even number, okay, like I move my thumb here, then it's just the average of those two middle ones. And then the mode, well, the mode is just the one that shows up the most often, okay, the one that's the most frequent here. Now, you can have multiple modes, okay, you can have bimodal data, you can have trimodal data, but once you get beyond 3 equally most often seen data values, beyond 3, statisticians usually say, okay, well, there's no mode, okay? I can have 2 modes, I can have 3 modes, but okay, 4 modes is starting to get to the point where, okay, really, can you really say that something is the most frequent if there's 4 of them? Well, probably not. So usually that's about as far as we go. Okay, these all have their place. I'm just going to run through this really, before we get into some examples of calculations really quickly here. The mean, okay, you're very familiar with the mean, but there is a problem with the mean. The mean is what we call sensitive to outliers. Meaning, let's say that my hand here represents where your average is, and all of a sudden you have one exam mark that's down here, like something bad happened that day and you couldn't focus, whatever. You will notice your average drop because of that data value. And it works the other way too, like one really high mark can pull your average up, but it's sensitive to outliers. Now the nice thing about the mean though is it takes all the data into account. All of it gets used to figure out the mean. The median is not sensitive to outliers, okay? But it doesn't take all the data into account. I mean, all we're doing is looking at the middle data value. That's it, okay? But that can be useful, okay? That can be quite useful here. For example, let's say that you've got a city block of houses here, but somebody buys the house at the end of the block, tears it down, and erects this enormous house here. You might say, well, what's the average house price here? Well, that one house price is going to raise the mean of all of them. In fact, the mean might now be greater than the house prices of all the other houses on the block. So you might not use the mean for that. You probably want to use the median. The mode is used frequently, let's say in retail, because let's say you're selling, I don't know, let's say hats. Well, you're probably not going to stock up on the mean size of hats because that might not even make sense, because the mean doesn't even necessarily have to be a value in the data. Neither does the median for that matter. You're going to want to do the one that shows up the most often, okay? Anyway, that just gives you an idea of when they're used, when they're not. Let's go through and do some calculations now. Okay, let's jump in here. So the question says, Jacob drives to school every day. The data below represents the time taken to the nearest minute for him to drive to school on each day of the last 15 days. So the first question is calculate the mean driving time. Okay, let's push that off to the side here. So let's just go through and do it here. So to find the mean, remember what I do is I'm going to add up all the data values and then divide by the total. So what have I got there? I've got 11 plus 13 plus 18 plus 10 plus 16 plus 15 plus 19 plus 15 plus 16 plus 17 plus 14 plus 10, 10 plus 14 plus 12 plus 13, okay? And then there are 15 data values there total. So now we divide by 15 and we get 14.2. So his mean driving time, okay, his mean here is going to be 14.2 minutes when we add those all up. Now let's look at the next question here. Why would the mode not be the best measure for central tendency for this data? Well, okay, when we take a look at it, remember the mode is the one that shows up the most often. Well, what have we got here? 10 shows up twice, 11 once, 13 twice, 14 twice, 15 twice, 16. Okay, I have now got so many. Okay, I have, what is it? I think when all said and done here, I think we have 5 modes, which means really there's no mode. Okay, there is no time that shows up the most in this data. Okay, so that's why the mode is not very helpful here, because there isn't one. And, you know, that happens. Okay, this question says, consider the heights in inches of 12 students on the Ross Shepherd football team. Okay, so here we go. Now I want to calculate the median. Well, so what I got to do to start off with here is I have to put these in the correct order. If you just jump through, count them and figure out what the middle one is, that doesn't help here. So let's take a look here. What's my lowest number? 65. And then what do we got here? 68. Okay, 68, 70. And then we got a 71, 72, 73. No 74, but there is a 75. There's a 76 and 2 77s. Okay, so now it's in the correct order. So now what have I got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I've got 10 data values, which means this breaks up nicely into 5 and 5. 2, 3, 4, 5. Okay, so there is no distinct middle. So now what I do is I take those 2 middle values here. I'm going to take 72 plus 73 and divide that by 2. Now the nice thing is I don't really have to do that. 72 and 73 only differ by 1. So my answer here is going to be 72.5 inches. And that would be the median. Let's take a look at another one here. Consider the following data: 10, 4, 7, 12, 9 for x, and 6. If the mean of the data is 7, determine the value of x here. Okay, this is a good one here, a good question. Because the idea of a mean is not that complicated. So all we're doing here is forcing a little bit of algebra onto the problem. So what have we got here? 10, so we got 1, 2, 3, 4, 5, 6, 7, 8. So I know that my mean here is going to be calculated by adding those all up. Plus 12, plus 9, plus 4, plus x, don't know what that is, plus 6, all divided by, I think I just forgot, 1, 2, 3, 4, 5, 6, by 8. And the answer here should be 7 when I do that. Okay? So now, one of the things you got to understand about algebra, and where I sometimes see students where it breaks down for them here, as soon as they see the unknown there, the thinking that they get is, well, I can't add those all together because I don't know what that one is. And yeah, that's true, but do as much as you can. Pretend that number is there, you just don't know what it is. Just move forward with it as much as you can. So what I mean by that is, I can't add up all of the values in the numerator here, but I can add up most of them. 10 plus 4 plus 7 plus 12 plus 9 plus 4 plus 6. Well, if I add those all up, I get 52. I still don't know what the x is. So I get 52 plus x over 8 is equal to 7. Now, I already know that the average is 7. Now, remember what that means. When we talk about the average, we're saying it's kind of the middle. And so what we're saying here, for example, if you take a classroom and we ask, well, what's the average mark in a class? And we say it's, let's say, 75. We're kind of assigning the value of 75 to that group, to everybody. So this right here is assigning the value of 7 to everybody. Well, what that would mean is that it's kind of like interpreting this as if it was 7, 7, 7, 7, 7, 7, 7, 7. Okay, that's sort of how it's behaving. In other words, there would be 8 sevens. In which case, if you added those all up, you would get 56. Now, clearly, another way that I could have explained that is you simply, because the unknown is right here, you could just multiply, okay, this whole equation here by 8 to get the 8 out of the denominator. But I also want you to understand conceptually what we're doing here. In the numerator, we're adding up all the data values, but the average is a way of explaining how each data value sort of behaves in that group. Anyway, now I would just subtract the 52 from both sides, and I get that x is equal to 4. Okay? So that's the value of x. Okay, next one. The data on the right, okay, represents the number of saxophone solos Cody received in the jazz band during his high school career. Okay, so we're going to calculate the mean, median, and mode for this data right here. So first of all, let's do the mean, okay? And so this is an entire population here. This is everything in high school. So what have we got here? If we add those all up, we've got 1, and 1 is 2, and 3 is 5, and 1 is 6, 2 is 8, 9, 10, 11, 12, 16, 17, 18. So when we add those all up, we've got 18 divided by 1, 2, 3, 4, 5, 6, 7, 8 times 2 is 16. Okay, and so, okay, 18 over 16, well, we got a common 2 there. So 9/8, sorry, 9/8. And I wrote 18. Okay, hold on. Let me fix that. 9/8. And so we divide that out here. So essentially, it's got about 1.1 solos per song. Is basically what that's saying. Okay. Now let's take a look at the median. Now to do the median, what we need to do here is we need to write these all out in order. So I've got 1, 2, 3, 4, 5 zeros. Okay, so 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7 ones. 1, 2, 3, 4, 5, 6, 7. 1, 2, 2 twos. 1, 3, and 1, 4. Now just to double check here, let's make sure we've got enough of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. Yeah, 16. Which means this splits it up into 8 and 8. Okay, and so the middle one here is going to be the middle 2 here. 1, 2, 3, 4, 5, 6, 7, 8. So the middle 2 will be 1 and 1. So our median here is going to be 1. And now let's take a look at our mode. Okay, our mode is going to be the one that shows up the most often here. Well, we just figured that out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So the mode is 1. Okay, and there you go. Okay, now we're going to do the exact same question here, but this time we're going to let the calculator do most of the work. I'm going to show you how this works here, because it's kind of cool. Okay, most graphing calculators will have the ability to do this here. So I've got the TI-84 here. And so what I'm going to do here, I'll try to work this thing through so it makes sense. And I'm getting a little bit of shine here, so I'll hold the calculator up. So the first thing we're going to do here is I'm going to press Stat. Okay, and so your Stat button, well, it's right there. Okay, right in the middle there says Stat. Oh, make sure that'll make me work if I just put it down. Oh, sometimes that doesn't work. Now, once I press the Stat button, I'm going to press Edit. Okay, just Enter for Edit. And that gives me my lists here. Now I'm going to show you a couple things here. Now I've already got data in here in list 1. I'm going to zoom in this because I want you to see this. I've got data here in list 1. Now that's where I want to put the data that I just found here. But here's what happens. I can delete this. I can press delete and just get rid of this one data value at a time, and that works. Or I can move up to list 1 here. Now watch what happens here. I'm going to press delete. Okay? I'm going to press delete. Now, do you see what just happened there? It just got rid of list 1. I still wanted list 1 there. Now it got rid of it. So now, oh boy, I got to get list 1 back in there. Well, the opposite of delete is insert. So I'm going to press second, insert. And what that does is that opens up a new list here. The names for your lists are down here above your buttons 1 through 6 here. So I want to get L1 here, which is just above 1. So I'm going to use my second number 1 here, which puts the name L1. I'll press enter. And actually there it is. And it didn't delete it off of the calculator's memory. It just got rid of it. It didn't show it anymore. The way you really want to get rid of this is you go and highlight L1 and then press clear. And it sits here with the L1 like this. It's basically saying, are you sure? And now if I press enter, it gets rid of everything. So now what I'll do is I will enter, and I'll zoom out here just wrong way. I will zoom out here to enter in this data. So I'm going to just go across here. So 1, enter 0, 0, 1, 3, 1, 0, 2, 0, 1, 1, 2, 0, 4, 1, 1. And that's all my data. Okay, so now once that's done, I'm going to quit. I'm going to get back to my home screen here. And now what I'll do here is I'm going to press stat. Oh, wait a second, I lost track of it. Stat. And I'm going to go over to the calc menu. And now what I want to do is I want to stay right here with one variable statistics. I don't want to use two variable statistics, just the one variable statistics. Now my calculator specifically gives me this opportunity to tell it what's going on here. I've got my data in list 1, okay, and that's true. All my data is in list 1. I've got my frequency list here. Now, if these things show up with a different frequency, and I'll show you that an example in just a moment here, I would change that, but I'm going to leave that blank right now. I'm just going to go right down to calculate. And when I press calculate, boom, it gives me a lot of that information. So the mean is 1.125. So my mean here was 1.1. I go down here. This gives me a lot of information. Now that little funky symbol right there means sum. So this means if I add all up the data values, I get 18. If I add up the squares of the data value, I get 4. Then we're talking about sample, what we call standard deviation here, and then so population standard deviation. Don't worry about that. N is the number of data values that I entered. Now that's reassuring because I knew from before that it was 16, but it means that I entered that in correctly here. And then it gives me a list of data about the spread of the data. The one that I want right now is the median. And it says here the median is 1. Okay? Now on my lesson here, it says the number of values, n was 16. And that's exactly what I wanted. And it says here, note the calculator will not give you the mode. Yeah, it's not going to do that for you here. Now, that's if you have a TI-84. If you've got the TI-83, you just enter in the arguments here, which means when you enter one variable statistics, you need to get the L1 to sit out at the back then. Like my calculator wrote this. You'll write one variable statistics. For the most part here, you don't even need to do this. If you've put the data in list 1, if you just press enter after that shows up, the calculator assumes you meant list 1. But that's just another nice little way of coming up with all of those that information based on a list of data. Okay, now we're going to take a look at another way of handling information. We're going to call this a frequency distribution here. What it says here is often there's too many data values to write them all in one column or in one line. It's just the data becomes a little bit bulky. It's awkward to work with. Okay, so what we've got here says, for example, the data below represents the number of pets 32 students have in a Math 10C class. Okay, well, instead of writing out all 32 numbers and even entering that into my calculator at some point here, what I'm going to do here is I'm going to take a little bit of a shortcut. I'm going to identify the data values that I see here in the first column, and then I'm going to identify the frequency that they show up in the second column. So what I mean by that is I've got 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9 twos. 1, 2, 3, oh, 3 threes, that's it. 4, I've got 1, 4, 2, 2 fours. And then for 5, I've got 1, 2 fives. Now, the question here said that there were 32 data values here. So I'm just going to add up my frequencies here. So I'm going to add 8 plus 8 plus 9 plus 3 plus 2 plus 2. And I do get 32. So that is correct. That's a good sign that I counted those correctly and I didn't miss something. Okay, so now let's go down here and let's calculate the mean, median, and mode for the number of pets here? Well, I already know that there's 32. Okay, I already know that there's 32, and this is going to be my whole population here. So I know I'm going to be dividing by 32 here. Now, instead of going 0 plus 0 plus 0 8 times, I'm actually going to use that operation that I just said. I'm going to use multiplication. I'm going to use times here. 0 times 8 plus 1 times 8 plus 2 times 9 plus 3 times 3. Now I'm going to come down. Well, I'll just keep going. Plus 4 times 2 plus 5 times 2. All of that over 32, because I know that there's 32. So I'm just going to take advantage of the frequency here and use multiplication to get through that a little bit quicker. So now on my calculator, okay, that'll look like this. I'm going to put brackets there. Now I could do 0 times 8, but I don't need to because I know that's going to be 0. I also know that 1 times 8 is going to be 8. Okay, and now I can go 2 times 9 plus 3 times 3, although I can do those calculations pretty easily here. But we'll just do it like this. Plus 5 times 2. Close brackets. We're going to divide by 32. Okay, so on average, we've got 1.7 pets per student. Okay, 1.65 or 1.7 pets per student. Now, does anybody here actually have 1.7 pets? Well, no, but that's a way of understanding those numbers here on average. Now, our median, okay, our median is going to be, remember, the middle value or the average of the middle two. Now, I already know that there are 32 data values here. So what I got to do is I just got to come down here and figure out, okay, well, where's, where are the 16th and 17th values? Because remember, if there's 32, that's going to break into two groups of 16. So the final number in that first group will be the 16th number. The first number in the second half will be the 17th number. Well, that's going to be right here. Okay, 8 and 8. 1 is going to be the 16th value, and 2 will be the 17th value. So the median here is going to be 1 plus 2 divided by 2, or 1.5. Okay, so the middle will be 1.5. I hope that makes sense here, okay? It has to do with remember when you add these all up here, but notice that the majority of these data values show up here, and it trails off at the end here. So it does make sense that it would be slightly skewed towards the top of that chart there. Now the mode, and this is, once you've got it in a frequency chart here, the mode is the easiest one to do, because the mode is going to be the one that shows up the most often, in which case that's the 2 here. It shows up 9 times. Okay, remember, this is the data that we're analyzing. This is the number of times this data shows up in our data set. Now, it is convenient, that we can do this on the calculator. Okay, so what I can do here is I can press Stat, Edit. Now, I've already got data in there from that previous question, so I'm going to get rid of that data by going up to L1, pressing Clear and then Enter. But now what I'm going to do is I'm going to add a frequency distribution here. So I'm going to go up and I'm going to take this chart that I entered up here. In list 1, I'm going to put the actual data. So 0, 1, 2, 3, 4, 5. And then over here I'm going to put the frequency 8, 8, 9, 3, 2, 2. Okay, so now the frequency table is in. So I'm going to quit now. Now, I'm going to tell the calculator that what I just calculated, what I entered in there was a frequency chart, and I'm going to do that by pressing Stat, Calc. Now, it might be very tempting to choose 2 variable statistics because you've got two columns in that chart there, okay, list 1 and list 2. But remember that there is only one set of data. It's just list 1. List 2 is just telling you how many times those data values in list 1 show up. It is only one set of data. The data is only the number of pets that students have. So what we're still going to do is we're going to choose list 1 here again, or that one variable statistics. But now what I'm going to do is I'm going to let the calculator know the frequency is in list 2. And I'll do that by pressing second 2, and it'll put list 2 there for me. Press enter and then calculate. Now, when I do that, one of the very first things that I'm going to do is I'm going to look at N. So N tells me that there are 32 data values entered. Good, that's perfect. That's exactly what I needed it to say, because I knew that there were 32 data values in here. Okay, so let's just take a look at this. My mean, okay, was 1.7. Good, I got that from before. Now let's go down to the median. The median was 1.5. Perfect, that's exactly what I calculated. Okay, so that worked out great. Okay, so in this last question we read that Mrs. Lee Mitra was counting the number of cases each student sold for Chinese grad. She represented her data on the frequency table below. Okay, so let's grab our, our calculator here. So we're going to enter the data in. So stat, edit. Oh, and now remember, I've got data up here, so I'm going to get rid of that first. So I'm going to go up to the title and press clear, enter. Clear, enter. And I'm going to enter the data in. So 0, 1, 2, 3, 4, 5, 6. Oh, and I forgot the 0. So there we go. And here, 1, enter, 6, enter, 19, enter, 17, enter, 5, enter, 7, enter, 2, enter. And I like to see that the number of kind of rows that I use match up in both cases there. Okay, so now I will quit, and we're going to go back into the stat, over to the calc, one variable statistics, and I'm just checking here. List 1 is where my data is. The frequency list is list 2, so I should be good to calculate. All right, so there's the information there. Now let's go through and look at the questions we're being asked. It says, how many students were fundraising for the Chinese grad? Well, that's going to be my N here. I trust that I entered that in right there. That's going to be 57. Okay. What is the mode number of cases? Now remember, the calculator won't show you the mode, so we got to go back over here, but that's actually pretty easy to tell because I'm simply going to look at the highest frequency, 19, and the answer there is 2. What's the mean number of cases sold by a student? Well, I come over here and I can look at my calculator here. The mean, there's my X with a bar, is going to be 2.8. And there you go. Calculator makes a lot of that much, much easier to do.